trig functions are ratios of the sides of a right triangle, so we have to name the sides. Let's call the angle theta. We all know that the longest side is called the hypotenuse. The side opposite theta is called its opposite side, duh. And the third side is called its adjacent side. If we know two sides of a right triangle, the Pythagorean theorem gives us the other side. The hypotenuse squared is the sum of the squares of the other two sides. These other formats simplify our work. The easiest way is to keep in mind the hypotenuse is the longest side. So to find the hypotenuse, we add, whereas to find the shorter sides, we subtract from the hypotenuse. Now we can define the trig functions. To begin, we need only two, the sine and the cosine. The sine of an angle is defined to be its opposite side divided by the hypotenuse. Suppose you use the large triangle and your friend uses the tiny one. Do you get the same value for sine theta? Yes, because the triangles are similar. So we don't have to worry about that. The cosine of an angle is defined to be its adjacent side divided by the hypotenuse. We will use two important triangles as examples. First, the 30, 60, 90 degree one. Let's figure out the sides of such a triangle. A clever way is to cut an equilateral triangle in half with a perpendicular bisector. To avoid fractions, let's choose 1 and 2 as the lengths of the sides. How do we find the other side? Of course, the Pythagorean theorem. Square root of 2 squared minus 1 squared is the square root of 3. Now we are ready to find the sine and cosines of some angles. Let's find sine of 30 degrees. Sine is opposite over hypotenuse. The opposite side of 30 degrees is 1. The hypotenuse is 2. So sine of 30 degrees equals 1/2. Let's find sine of 60 degrees next. Same thing, opposite over hypotenuse. Look at the angle 60 degrees. Its opposite side has length square root of 3. So the sine of 60 degrees equals square root of 3 over 2. Okay, on to the cosines. Cosine is adjacent over hypotenuse. The adjacent side of the 30 degree angle is square root 3. The hypotenuse is 2. That means cosine of 30 degrees equals to square root of 3 over 2. The adjacent side of the 60 degree angle is 1. Hypotenuse is 2. That means cosine of 60 degrees is 1 over 2. Here's a summary of our results. Let's look at another important right triangle, an isosceles right triangle. For the equal signs, the simplest numbers to use would be 1 and 1. The two acute angles are 45 degrees. Let's find the hypotenuse. Square root of 1 squared plus 1 squared. Easy. Square root 2. This triangle is complete. Now we can calculate the sine and cosines of 45 degrees. Okay. Sine is opposite over hypotenuse. Doesn't matter which angle you look at, the opposite and the adjacent sides are both 1s. So opposite over hypotenuse, adjacent over hypotenuse, all come out equal to 1 over square root 2. So let's repeat that to ourselves. Sine of 45 degrees equals 1 over square root 2. Cosine of 45 degrees also equals to 1 over square root 2. Do you think we can guess the sine of 0 degrees? Let's try. Imagine a right triangle that has a 0 degree angle. The hypotenuse is the same as the adjacent side, and the opposite side has length 0. So the sine of 0 is 0, and the cosine of 0 is 1. Okay, now that we're experts on the sine and cosine functions, yeah, right. Let's move on to the other 4 trig functions. They all come from sine and cosine. Tangent is sine over cosine. Cotangent is cosine over sine. Secant is the reciprocal of cosine. And cosecant is the reciprocal of sine. The last two are harder to remember. To avoid confusion, note that the S's and the C's go together. Look at the picture, the S's and the C's. Of these 4, tangent is the most important. In fact, we use tangent so often, we should memorize what side over what side it is. Let's find out. Tangent is sine over cosine. Substitute opposite over hypotenuse for the sine, adjacent over hypotenuse for the cosine. The hypotenuse cancel out, and we're left with opposite over adjacent. So here's the result. Tangent of theta is its opposite side over its adjacent side. Now we can find the other 3 just by taking reciprocals. All set? Let's continue. We'll do an example. This right triangle has hypotenuse 13 and the side opposite theta is 5. To find the adjacent side, we'll use the Pythagorean theorem. Let's call it A. We get A is equal to the square root of 13 squared minus 5 squared. That's square root of 169 minus 25, which becomes square root of 144, and that's 12. Now we can look at the triangle and read off the trig functions. Sine is opposite over hypotenuse. We get 5 over 13. Cosine is adjacent over hypotenuse, so we get 12 over 13. Tangent is opposite over adjacent. That comes out to be 5/12. Now let's take the reciprocals of those. 1/sine is the cosecant, so that's 13/5. Secant is 1/cosine, that's 13/12. Cotangent is 1/tangent. We get 12/5. That's it. I'm going to give you a very, very useful table. We use this so often in calculus that I know this table better than the multiplication table. I actually find the results amazing. Because look at the first row, the sine theta row. See the numbers on top? They're like 0, square root 1, square root 2, square root 3, and a square root 4. They're all divided by 2. So they go from 0 to 1, 2 is always on the bottom, and the top is square root 1, square root 2, square root 3, square root 4. That's pretty strange, isn't it? Now cosine, you just copy that backwards. Start with the 1, go down to 0. To get the tangent values, you take the sine value and divide by the cosine value. So notice how the tangent goes. It starts at 0, 1/square root 3, 1 square root 3. So that's pretty easy to remember too. You know what I'm going to do next, right? Give you homework. Yes, just one problem. So give it a try. Good luck. Bye.